Now let's talk about exterior angle measures. Let's start with a little exploration. Identify each exterior angle and calculate the sum. Remember, sum is when we add of the exterior angles for each polygon. Here we have a triangle where the interior angle measures are shown. We remember that an exterior angle measure is made by extending the side of the polygon so that we get an angle on the outside. We remember that because this angle and this angle make a linear pair, that together they have to add up to 180 degrees. Therefore, to find this exterior angle measure, I think what is 180 minus 50, that makes 130. So this exterior angle measures 130 degrees. Similarly, this exterior angle measure up here, 180 minus 60, 180 minus 60 measures 120. So that's this angle, 120 degrees. And then finally, for this last exterior angle, 180 minus 70 makes 110. So this exterior angle is 110 degrees. Now remember, it said to calculate the sum of all of the exterior angles for the polygon. So we have 130 plus 120 plus 110. And when we add those up, it makes 360. So these exterior angles add up to 360 degrees. Let's take a look at the quadrilateral that we have over here. Remember, 1, 2, 3, 4 angles means 4 sides. Therefore, 4 is quadrilateral. Just like in the triangle, we can make an exterior angle by extending the side of the polygon. And then we have a linear pair, which of course adds up to 180 degrees. So when we figure out that exterior angle, 180 minus 91 makes 89. This exterior angle measures 89 degrees. Then we have this side extends here for the 92-degree angle. Its supplement is 88 degrees. Next to the 87-degree angle, 180 minus 87 is 93 degrees. And finally, we know this symbol means it's a right angle, which is 90 degrees, and supplementary of the 90 degrees is also 90 degrees. So we will again calculate the sum of these exterior angles. We should have 4 because we have a quadrilateral. There they all are. Let's add them up. 88, 93, 90, and 89. What do we get when we add those up? 360. So again, 360 degrees is the sum of the exterior angles. In fact, that is what the Polygon exterior angle theorem tells us. The sum of the measures of the exterior angles of any convex polygon is always 360 degrees. All the time, no matter how many sides or angles. Now, if you have some time, I would check out this website where you can explore with all different kinds of geometry things, especially in this case, the polygons and the exterior angles. I'd like to do one more exploration with you, or rather a demonstration, so you can see how that works. Now here I have a pentagon. Notice there are 1, 2, 3, 4, 5 angles, therefore 5 sides. These are, and 5 is pentagon. These are the exterior angles that I've drawn numbers in, and I've actually made it so that I can take out each exterior angle. Remember where the vertex was, where the number is sitting, and I'm going to put these angles vertex to vertex. I want you to notice something after I put all of them vertex to vertex. So I'm matching up where the vertices of the angles are. Notice how they all fit in there quite nicely. In fact, if I were to add up this angle and this angle and angle 3, and angle 4, and angle 5, they make a complete circle. Do you remember how many degrees a complete circle is? 360 degrees. So the exterior angles put together make 360 degrees. Let's do it one more time with another type of polygon. This one has 1, 2, 3, 4, 5, 6 angles, therefore 6 sides. 6 is hexagon. So I'm going to take each of the exterior angles from the hexagon. Notice that's different from a pentagon. Put each of the exterior angles vertex to vertex and see what happens. So again, putting them vertex to vertex, they all fit in there perfectly. In fact, if I were to add angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6, that's all the way around a circle, which again is 360 degrees. Just another reminder that exterior angles put together make 360 degrees. Let's apply that to some examples. In this example, our directions are solve for x. Notice where the x's are. Outside of the polygon, and I see a degree mark. The degree mark means that this is representing an angle measure. Because they are outside the polygon, these are exterior angles. And remember that exterior angles have a sum that is equal to 360 degrees. And remember that sum means we need to add up those angles. So that's what I'm going to do. Let's start with this one, and I'm going to put a little mark here so I remember I already wrote that one. 2x plus 60, and the next one, 3x plus 2. Notice that I'm lining them up with like terms because I need to add them. Then I've got 3x minus 5. Next, 2x plus 3, 4x plus 10, and x minus 10. Remember, when we don't see a number in front of the x, that's an invisible one. Remember that my exterior angles always add up to 360. So I'm going to add these angle expressions to 360. All of these x's, 3 plus 3 is 6, plus 3 is 9, 11, 15, 16. Did I do that right? Let's double check that. 5, oh, that's 2 plus 3, 5, 6, 7, 8, 9, 10, 14, 15. That's 15 x's. When I add up all these constants, I get 60, and that's supposed to make 360 for all types of polygons, no matter what they are. Now we can solve this equation for x. Subtracting 60 from both sides, we get 15x equals 300. Then dividing both sides by 15, we get x equal to 20. Have we answered the question? Solve for x? I believe we have. There we go. Let's take a look at a couple more examples. Find the measure of an, remember that an means one, exterior and an interior angle of the indicated regular convex polygon. Remember that regular means equilateral and equal angular. Basically, all the things congruent. Equal measures of the sides, equal measures of the angles. Now this is a regular heptagon. Remember that a heptagon means that there are seven sides, therefore 7 angles. So if there are 7, we know how to deal with that. First of all, the sum of the exterior angles is always 360 degrees, no matter what. If I want just one of those exterior angle measures, and they are all congruent angles, then we divide 360 by how many we have. Now 360 divided by 7, we have to round that. It doesn't go in exactly, but that's okay. These angle measures happen to not be exact. 51.4 degrees is how we will round those exterior angle measures. Now remember that the interior angles, and we only want one of them, are linear pairs to the exterior angles. Remember that? So if we have a 51.4 degree exterior angle, the interior angle is supplement to that exterior angle, supplementary. So we subtract from 180. 180 minus 51.4 makes 128.6. So that interior angle is 128.6 degrees. Let's take a look at another example, the last one here. Given the measure of one exterior angle of a regular convex polygon, state the number of sides. 24 degrees is the measure of one exterior angle. So remember, in this example, we did 360 divided by how many sides, and it gave us the angle measure. That means 7, the number of sides, times 51.4 approximately will equal 360 degrees. So if we said 7 sides by itself, we would be dividing by 51.4. So if I need to know the number of sides, I can take the angle measure and divide it into 360. That's what we can do here. 360 divided by that angle measure, which makes 15. That's the amount of angles, therefore that's the amount of sides. 15 sides, and if we had to classify it, we would call it a 15-gon. Hope you learned some fun stuff today. Thanks for watching.